Aloha and welcome to our video on the Earth's layered structure. In this video, we'll talk about the layers of the Earth, and then we'll also talk about how scientists determine the Earth's structure and composition. Now, when we talk about the structure of the Earth and its layers, we start off knowing that there's three basic layers to the Earth. We have the crust, which is the outermost edge. We have the mantle, which we're going to see in this portion here, and that's broken down into the upper and lower mantle. And then we have the core of the Earth, and that also is broken down into two layers. We have an inner core and an outer core. The crust is what we typically think of as the rock. Okay, it's the lithosphere, it's the sphere of rock. We have two different kinds. We have continental, which forms the land masses, and oceanic crust, which forms the bottom of the ocean. The very top of the mantle is also going to be a rock, and that forms the lithosphere, which we can see here as being a little bit of the crust and the upper mantle. Below that is the asthenosphere, and that's what the plates slide over. So it's a more liquidy layer of rock, and that's what the plates are moving on when we talk about plate tectonics. Now, below the mantle, we have the core, and we have two different cores there, one's solid, one's liquid. And the interaction between these two, the rotating of the core, is what generates our magnetic field. So we have a magnetic north and a magnetic south. We'll learn that that can flip every once in a while. And this is what our compasses are attracted to. We have this magnetic pole, and our compasses are going to point towards magnetic north. So it's not true north, which is geographic, but it's going to point towards magnetic north. And that's generally close enough for our navigation purposes. So the lessons will go through these layers in a little bit more detail. I just wanted to show you where they are and show you a quick picture of it. But also how we study them kind of is an interesting story in itself. We can look at the crust and we can study the crust fairly easily. We can go down to the bottom of the ocean and collect samples from the oceanic crust. Continental crust you can go out in your backyard and find the samples of. So that layer we know fairly well. To get to the mantle is where we run into problems, because if you were to dig to the mantle, as soon as you broke through, you'd create a volcano, and that's generally not a great place to be studying. So most of our knowledge of the inner layers of the Earth comes from the study of P waves and S waves and how they move. So by studying this movement of the P and S waves as they traveled through the Earth, it gave us an idea of what was solid, what was liquid, how dense it was, and that's how we've painted the picture of what the inside of our planet is like. So our knowledge of the inside of our planet is based mainly on evidence that we assume coming from these wave patterns, but also by studying some of the products that have been brought up. That's how we know a little bit about the mantles, by looking at lava flows and things like that. But we can't actually get down into the mantle or into the core to study it. So most of our knowledge comes from indirect methods. Okay, so that's it for our video today. Good luck on your quiz and your lessons, and we'll see you in the next video.